In archaeology, understanding when artifacts and sites were created is, absolutely crucial. This process is called dating or establishing chronology. Accurate dating helps historians and archaeologists prove how old something is, which in turn gives credibility to our knowledge of ancient civilizations. Without proper dating, history would be full of guesses rather than facts. Dating allows us to place archaeological finds on a timeline. For example, dating methods confirmed that the Indus Valley Civilization was one of the world's earliest urban cultures. Sites like Kalibangan and Lothal were linked to the Harappan culture through dating, showing their importance in history. If we didn't have reliable ways to date these sites, we couldn't be sure when they existed, and their achievements might be overlooked or misunderstood. Sometimes coins or seals found at a site can give clues about its age. However, these clues are not always enough. That's why archaeologists use scientific dating methods, which are more accurate and reliable. Using more than one method to date an object or site makes the results even more trustworthy. There are two main types of dating methods in archaeology. Relative dating. This method tells us whether something is older or younger than something else, but not the exact age. Absolute dating. This method gives us a specific calendar date or range of years for an object or site. So, absolute dating gives us actual dates or date ranges for artifacts and sites. These methods, rely on natural processes, like radioactive decay or even the growth of tree rings. Here are some of the most important absolute dating methods. First up, radiocarbon, or C14, dating. Radiocarbon dating is actually one of the most widely used methods for dating organic materials, such as wood, bones, or shells. This method was developed by Willard Libby back in the 1940s, and he later won a Nobel Prize for his work. So here's how it works. All living things absorb a small amount of radioactive carbon, or C14, from the atmosphere. When they die, they stop absorbing it, and the C14 slowly decays. By measuring how much carbon-14 is left in a sample, scientists can calculate when the organism died. This method works for things up to about 70,000 years old. For example, radiocarbon dating has been used to date Egyptian artifacts and ancient trees like the bristlecone pine. There are some challenges with radiocarbon dating. The amount of carbon-14 in the atmosphere can change over time, which can affect results. Also, if old wood is reused in a newer structure, it can give a misleading date. To fix this, scientists often cross-check radiocarbon dates with other methods, like dendrochronology. Now let's talk about dendrochronology, or tree ring dating. Dendrochronology is the science of dating wood by studying tree rings. This method was developed by A.E. Douglas in the early 1900s. So here's how it works. Each year, a tree adds a new ring, right? The thickness of each ring actually depends on the climate during that particular year. By comparing the pattern of rings in a piece of wood to a master sequence of known ages, scientists can, figure out exactly when the tree was cut down. This method works best for the last 3,000 years, especially in areas where trees have long lifespans and really clear ring patterns. For example, dendrochronology has actually been used to date ancient Native American villages in the southwestern United States. One limitation is that this method tells us when the tree was cut, but not necessarily when the wood was actually used. Sometimes old wood is reused, which can, honestly, give a false impression of the age of a site. So, for the best results, dendrochronology is often combined with radiocarbon dating. So, let's talk about potassium-argon dating. Potassium-argon dating is actually used to date volcanic rocks and ash. It was developed by C.F.E. Weizsäcker and later applied by W. Gentner. Here's how it works. When volcanic rocks form, they trap potassium, specifically K40, which slowly changes into argon gas over time. By measuring the ratio of potassium to argon in a sample, scientists can calculate how long it has been since the rock solidified. So, potassium-argon dating is actually super useful for dating rocks that are between 30,000 and 300 million years old. For example, this method has been used to date the layers at Olduvai Gorge in Africa, which is where some of the earliest human ancestors were found. Now, there are a few limitations to keep in mind. If the rock loses argon gas after it forms, the results can end up being inaccurate. And honestly, this method only works on volcanic materials, not on artifacts made by humans. No single dating method is perfect, right? Each one really has its own strengths and weaknesses. That's why archaeologists, including myself, often use more than one method to check our results. For instance, we might use both radiocarbon dating and dendrochronology on the same piece of wood. If both methods give the same date, we can be much more confident that the date is correct. Dating methods are absolutely essential for understanding the past. They turn objects and sites into real evidence, not just guesses. The most important methods, radiocarbon dating, dendrochronology, and potassium-argon dating, have helped us build a reliable timeline of human history and the Earth itself. By using these methods together, archaeologists can make sure their findings are accurate and trustworthy, giving us a much clearer picture of our shared heritage